If you could switch off pain with a single gesture, would you do it? If you could erase a regret or instantly change a depressing thought, would anything remain of what we call morality? A technology called Neuralink, developed by Elon Musk, opens up the possibility of communicating directly with the brain, no longer merely studying it from the outside, but interacting with the cells of our nervous system. Every new technology humanity has conceived has not simply added tools to our repertoire. It has transformed, often in ways that are subtle yet radical, the very way we look at the world. The telescope expanded the sky until it made us feel tiny. The microscope revealed hidden universes within the fabric of matter. Photography froze time. The digital network compressed the planet into an almost instantaneous space. Every invention has not been merely an object, but a new lens through which to interpret reality. Today, however, we are crossing a different threshold. The latest developments in neuroscience and biomedical engineering make it possible to dialogue with the cells of our central nervous system, to modulate neural circuits, and to intervene, with increasing precision, on what we feel. Targeted electrical impulses can ease depression, switch off anxiety, and reduce pain. But this possibility raises questions that belong not only to medicine. The technologies that now interact with the brain promise to relieve devastating diseases and restore dignity to millions of people. Yet at the same time, they compel us to confront a question as ancient as philosophy itself. What does it mean to be human? At the moment when we become capable of intervening directly in neural circuits, we are not only transforming the way we treat neurological and psychiatric disorders, we are, perhaps for the first time in a direct way, redefining our very essence. This transformation does not necessarily begin with a chip implanted in the brain. It begins much earlier. It is the result of a scientific journey that spans almost a century of neuroscience. In the 1930s and 1940s, the Canadian neurosurgeon Wilder Penfield carried out some of the most extraordinary experiments in the history of neurology. During surgical procedures on awake patients, by stimulating different regions of the cerebral cortex with electrodes, Penfield discovered that it was possible to evoke memories, sensations, and movements simply by applying a targeted electrical current. For the first time, it became clear that specific mental experiences could be artificially activated in the brain. In the 1960s, another researcher pushed this idea even further. The Spanish neuroscientist José Manuel Rodríguez Delgado developed a device called the Stimulation, a system of electrodes implanted in the brain that could be controlled remotely through radio signals. In experiments that became famous, Delgado demonstrated that it was possible to modulate behavior, emotions, and motor impulses through targeted neural stimulation. His work showed that the brain was not only observable, it could be directly modulated. In the following years, neuroscientific research continued to explore this frontier. Among the most visionary contributions are those of the neuroscientist Rodolfo Linas, who proposed the idea of directly connecting the brain to digital systems. Linas envisioned the possibility of a bidirectional communication between brain and technology, not only reading neural activity, but also writing it, shaping it, influencing it, and dialoguing with it. A kind of wiring of consciousness. In recent decades, these intuitions have begun to turn into real technologies. Non-invasive techniques, such as transcranial magnetic stimulation, make it possible to modulate the activity of specific brain areas through a technology that acts from outside the skull using a magnetic field. At the same time, new brain-computer interfaces developed by Neuralink are moving toward increasingly direct connections between the nervous system and digital technologies. Founded by Elon Musk, the company is developing devices made of ultra-thin electrode threads implanted into brain tissue and connected to microchips capable of detecting neural activity. This information is then processed and converted into digital data, which is transmitted to a computer, enabling the brain to communicate directly with external technological systems. The initial aim is therapeutic, to help people with paralysis or severe neurological conditions regain lost abilities, such as controlling a cursor or communicating. Yet the broader vision goes further, creating a direct channel between mind and machine, where neural signals can not only be read, but also shaped. For the first time in history, human beings are developing tools that can intervene in the very space where perception and emotion originate. Within this radical freedom, where self-regulation and self-creation converge, the technical act transforms into an artistic gesture. The mind is no longer merely the subject of experience, but becomes at once material, medium, and artwork. It is precisely at this intersection of neuroscience, technology, and artistic experience that Neuropsychoart emerges. Neuropsychoart. Let us imagine a simple scene. A person walks into an ice cream shop. In front of them are 10 flavors. Which one will they choose? This apparently trivial question opens one of the deepest problems in neuroscience and the philosophy of mind. What is a choice, really? From this question arises the poetic and theoretical framework that I propose and that I have called Neuropsychoart. For centuries, Western culture imagined decision-making as the act of a unified self, a subject who observes the options, compares them, and freely chooses. But contemporary neuroscience tells a very different story. A decision does not originate in a single point of the brain. There is no single center of will. The brain is an immense network of interacting systems: memory, emotion, reward, cognitive control habit. These systems do not always cooperate. Often, they compete. Choice emerges from this competition. When we look at the flavors in the ice cream shop, the brain does not simply register information. It simulates experiences and activates memories. Multiple potential mental states appear simultaneously in the brain. We can imagine them as neural configurations attempting to stabilize themselves. A decision emerges when one configuration prevails over the others. The mind thus becomes a dynamic field of possibilities. When we speak about freedom or self-determination, we are not necessarily referring to a soul or an immaterial self. Freedom can also be described in neuroscientific terms. Neural self-determination means that the brain is capable of generating multiple potential mental states and allowing them to evolve through the internal dynamics of its own networks. In other words, choice is an emergent property of cerebral matter, the outcome of neural networks in conflict with one another. Within this framework, I propose thinking of art no longer as the production of objects, but as the exploration and modulation of mental states. For millennia, art influenced the mind indirectly, through images, through sounds, through stories. Today, technology opens a radically new possibility: to intervene directly in brain dynamics. What for decades was confined to laboratory experiments or theoretical speculation is now becoming a technological frontier. A frontier in which the mind is no longer only observed or interpreted. It can be stimulated, modulated, and perhaps one day even designed. In this perspective, the work of art is no longer an external object. It becomes a configuration of consciousness. Among the questions Neuropsychoart seeks to address is this: might there exist a minimal unit of the mind, a pixel of consciousness? From a neurophysiological point of view, there is a plausible candidate, the neural spike. An action potential lasts approximately 1 millisecond. Within that interval, a neuron activates and transmits a signal. We might imagine each millisecond as a frame of the brain, a complete photograph of neural activity. If the brain contains a finite number of neurons, then at every millisecond there exists a finite number of possible configurations, astronomically large, but finite. A mental state that lasts 1 second could be seen as a sequence of 1,000 neural frames, like a film. Consciousness would thus become a movie composed of successive configurations of the brain. And here, the central problem of Neuropsychoart emerges, a problem I do not intend to solve, but to expose. If the millisecond is the fundamental unit of neural activity, then every millisecond represents a unique and indivisible configuration of the brain, a total state. But what then happens to the theory of competition between mental states? If the brain, at every millisecond, possesses only one complete configuration, can we still speak of conflict between simultaneous mental states? Or does the conflict occur between successive configurations in time? In other words, do possibilities compete within the same instant or along the temporal sequence of instants? This theoretical tension becomes the heart of Neuropsychoart. On the one hand, neuroscience suggests that many neural networks compete simultaneously. On the other hand, if we consider the millisecond as the pixel of the mind, every instant appears to be a unique and indivisible configuration. The conflict might therefore not occur in space, but in time. The mind could be a sequence of configurations exploring different possibilities. This vision leads to a dizzying idea. If the brain is a finite system, then the space of possible mental states is also finite, immense, but finite. The mind would not be an infinite metaphysical entity. It would be a physical landscape of neural possibilities, a vast continent, but a bounded one. Neuropsychoart emerges as an attempt to explore this territory. Through neuroscience and emerging technologies, we might one day stimulate neural configurations, modulate mental states, allow new dynamics of consciousness to emerge. Art would become the exploration of the mental landscape. The art of the future might no longer produce objects. It might produce designed mental states, conscious experiences constructed with neural precision. In this perspective, freedom is not the act of a metaphysical self. It is the brain's capacity to generate multiple possibilities and move among them. Neuropsychoart seeks to expand this space, to increase the richness of the mental landscape. If the brain is a continent of possibilities, Neuropsychoart is the art of its exploration. This poetics that I propose does not claim to solve all the problems of consciousness. On the contrary, it seeks to place them at the center. To conclude this journey into a possible future of the mind, I will describe a work of Neuropsychoart inspired by Neuralink technology, the infinite present, a Neuropsychoart experience that explores consciousness through Neuralink technology. Time seems like something that flows, a continuous movement from the past to the future. But what would happen if that movement stopped? Infinite present. It is a Neuropsychoart experience designed to alter the structure of time in the mind. The subject is already equipped with an implanted neural interface, a system that directly connects brain activity to a digital environment. Seated in front of a simple, essential interface, they use neither hands nor voice. They select the protocol by thinking. A neural signal is recognized. The sequence begins. Time, in the brain, is a construction. The prefrontal cortex organizes the sequence of events. Temporal circuits build its continuity. It is from their synchronization that the sensation of flowing through time arises. The system intervenes right there. It does not interrupt, it does not block, but it introduces a slight desynchronization between these systems, a minimal variation, almost imperceptible, yet sufficient to weaken the very structure of before and after. At first, nothing seems to change. The subject breathes, observes. Then something subtle begins to shift. Moments stop connecting to one another. They no longer flow. They remain. There is no anticipation, no continuity. Each moment appears complete, self-sufficient. It leads nowhere. It comes from nowhere. It simply is. The after disappears. The before loses meaning. Only a present that does not pass remains, a present that does not evolve, a present that does not end. Nothing arrives. Time is no longer there. Without time, urgency fades. Things no longer happen towards something. They simply happen. Even meaning changes, because meaning without direction begins to dissolve. And with it, slowly, identity itself loosens. Who are you? If you are not going anywhere, who are you? If every moment is complete in itself, the system maintains the state for a few minutes. Then, gradually, it realigns the circuits. The sequence resumes. Time returns. But something remains, a doubt. If time is constructed by the brain, then what we call reality might be as well. This is not science fiction. This is Neuropsychoart,